Thank you, Alex. Thanks also, Sarin, for the organization of this webinar. It's nice to be with all of you guys coming from all over the world. So let me share the screen, and I'm gonna share a quick presentation about our master program. So tell me if you can see the screen.
We can.
Okay, excellent, excellent. So let's start from a little bit the explanation of what is the Master in Robotics and Advanced Construction, and what are we also sharing during this academic program and experience. So the Master in Robotics and Advanced Construction was born with the idea of creating a hands-on program that could interconnect the challenges from the industry, from the world of research, from the academia, but also from the realities that are implementing or they are struggling to implement a solution in the ecosystem of architecture and construction. So nowadays, after 5 editions, the master presents several formats. There is a 1-year format master program and a 2 years format master program with the possibility to do 1 year and shift to the 3D printing in architecture that will be presented later on. So our program is hosted by the main institution, the mother institution of IAC, the Institute for Advanced Architecture of Catalonia. IAC was founded more than 20 years ago, and nowadays IAC is distributed on the Catalan territory. You have 2 locations in the Poblenou district in Barcelona, and you have also 1 beautiful location in Val d'Aura between the mountains and trees and greenery. So the scope of IAC, generally speaking, is to promote research, but an applied research that can also be introduced in the professional ecosystem. For us, this is fundamental, also to prove and validate the goal and the content that we are sharing with all of you and teaching to all of you. So the mission of IAC is to understand and also promote the maturity of these novel solutions that are arising, or novel technological solutions that are arising in the technology panorama. And IAC has been doing so by, as I said before, by promoting hands-on projects, starting from the funding of the very first Fab Lab in Europe, fabrication laboratory that is hosted by our institution and is part of this of the core of what we teach. So how to design and how to make almost anything. So IAC is equipped with a series of digital fabrication machines, from robotic arm to CNC milling, etc. But evidently, one of our main goals is to connect digital tools with physical tools that can allow us to bring from the digital world to the physical world solution in our built environment. So we teach and we work with the most advanced computational tools and AI-driven algorithms, starting from the implementation of BIM, that is at the end the origin of all this system, to the generation of the whole ecosystem of Fab Labs that were promoted and initiated by the Fab Lab Barcelona, which is the original Fab Lab of Europe, and that became the most important node also to disseminate the Fab Lab culture, the fabrication, the digital fabrication culture. So nowadays, the IAC and the Master in Robotics, we rely on a huge ecosystem that goes from Catalonia to Spain to Europe, of companies and realities that are turning into realities the solution that we are exploring, from research centers and private companies here in Catalonia to the most famous companies of robotics in the world. So IAC in general promotes a transdisciplinary and multi-scalar approach to the evolution of digital design and manufacturing. So from cities to materials to machinery until the generation of proper spaces. And at the end, becomes IAC with all this transversality, it becomes a very important point to look ahead, to look into the future, to look also in the present, and start to ask why, no? Why are we in need of all these new tools? Why are we in need of all these solutions that at the end are useful for which reason, no? So an important asset of our reality is not that we are only technology providers, let's say like that, or promoters, but we also try to contextualize in a very specific environment and in a very specific discourse the implementation of these new technologies. So in the world of construction and regarding our built environment, let me admit other people entering, we are facing nowadays a series of challenges that are connected to the lack of adequate housing. So a lot of people in the world don't have access to houses. We also have to face the fact that our industry, the construction industry, is one of the most polluted industry in the world, is responsible for the 36% of greenhouse gases in the atmosphere. And also the need of standard or customized solution that can respond to the standard market application that is happening nowadays. So what do we need is a new way of construction. What do we need is the implementation of novel material solution in our built environment, and the possibility to generate a local logic and respond locally with a local intelligence to local needs. So several trends are arising. Evidently, I don't want to jump too much on this topic, but we know, all of us, we know that we are in the fourth industrial revolution. Is the revolution of the cognition, is the revolution of these machines that are capable of perceiving the environment where they are operating and are also communicating one with the other and with multiple actors that are now part of the manufacturing protocol and not only. So is the new era of cyber-physical solutions that connect the digital and the physical space. And in all these huge, incredible asset of opportunities, our field, the one of construction, is the less digital field in the world. So if you take all the possible sectors, even fishing and hunting, the sector of construction is less digital even than that. So this means that there is a big opportunity to implement novel solutions. There is a big market that can allow this trend to shift and the line to start finally going up. And one of the main reasons is also the cost and the availability of these solutions. I saw that Erika was entering. Okay, is the cost that is going down in terms of access to this machinery compared to the human labor. So for the first time in the history of humanity, the implementation of machines and the cost of machines is cheaper than the cost of humans. And this means that there is a new wave, no? This is the famous curve of innovation. So it's the moment of adoption. Is the moment of maturity. We are facing a new moment where finally whatever was thought in the 70s, all this beautiful research and investigation that were launched in the 70s about automation and architecture that respond and architecture that react, an architecture that is built using novel materials, ecological material, is possible today. So today is not a normal moment to start reframing your profession. Is the best moment. Is the best moment because it's the moment where the solution that you have in front of you are real, can be introduced for real in our ecosystem and built environment. So is the moment of rethinking whatever is possible to do in terms of digital fabrication. And in IAC, we try to do it by crossing the process, so the whole process, the rethinking the whole process, and I will show you several projects later on, rethinking materialities, rethinking machinery, and rethinking design protocols. So in terms of process, with our 6-axis robot, we've been basically applying any kind of possible end effector to a 6-axis robot. I don't know how many of you have familiarity with robotic manufacturing. In IAC, we've been pioneering the introduction of this kind of solution, and we've been exploring firsthand how to engineer, how to creatively rethink this hand, what this automated hand is capable of doing. So can it print, can it cut, can place, can also subtract material. And now every time we can adjust this end effector to a specific scope of application. And in doing so, we've been exploring multiple applications. This is a study that was done in IAC with a protocol of pick and place, adopting sticks from wood that can be upcycled and reclaimed from the industry and reuse in a novel way in order to maximize its application and also then construct something completely new. So this was a pick and place project that at the end show you a little bit how a microfactory could work. A microfactory where at the end you have your material resources, you have your manipulator in terms of material, and you also assemble these pieces together. And another project was made years ago with the support of Sasha Jogovic and Peter Novikov and the support of the whole IAC faculty team to start printing without any gravity. And in this case, again, we redesigned the end effector and we introduced a material composition that could allow the material also to stand in the air, and you can see here some of the results. A very interesting research that at the end was promoting this possibility of fabricating without the addition of any support, and using and adopting also the natural gravity as an additional force that can shape your final solutions. And again, this research goes on with the introduction of many materials that we explore in IAC, from normal wood to 3D printing clay to bioplastic, to the introduction of waste material into this new circular economy vision, the introduction of bioreactors as algae or other bacteria as mycelium, and the possibility also to create interconnected skins that can be part of a new interactive environment with the introduction of graphene and nanoparticles. So IAC has been promoting quite a lot the introduction of clay in the construction and design to fabrication solution. And in this environment, I mean, you can also see a little bit which is the protocol. So in IAC, more than 10 years ago, we started with the analysis and the possible exploration of clay manufacturing. And we went on with a proper analysis and studies where also one of our students built an incredible extruder that was used and still used incredibly almost 10 years later to fabricate with clay at a large scale, but also to study this material at the nanoscale in order to understand also the capacity of these fibers to be interconnected and the additive mixture that could facilitate at the end the natural hardening of this product. So this gives you also a sense on how we work across different scales in IAC and how our students at the end are exposed to a knowledge that really can be extremely diverse. So you can focus on the materiality, you can focus on the computation, you can focus on the robotic manipulation and manufacturing of the assembly. So these are multiple aspects that at the end bring together a novel concept, also creativity or novel protocols of construction that at the end also speaks about this industry 4.0, no? This capacity of machines to compute and understand where they are operating. So not only fabricating, but also scanning, collecting information for whatever from whatever is building, and then adapting their behavior and correcting whatever they are doing, thanks to this possibility to, at the end, provide a proper representation of their manufacturing environment. And this is done by the introduction of sensors, and I'll show you later on how this is important in our master, and the creation of a new loop. So you don't only apply a top-down approach. I design and the machine makes. No, you design, the machine starts to produce, the machine also reacts to the material, the machine reacts to whatever is fabricating and adjusts, no? And adjust its behavior, and also maybe eventually introduce creatively a new design solution. In terms of machines, in fact, also in the master in robotics and the history of IAC, we've been using a vast quantity of machinery, from Cartesian system to six-axis robot, the cobot, drones, and small robots, autonomous robots that can also rely on ROS. So here, for instance, these are this is a project that we presented in the construction fair of Barcelona, developed in collaboration with Tecnalia, so an important industry of Spain, one of the most important technology providers of Spain. And with them, we converted a machine that at the end is thought for pick and place, for moving object, into a new 3D printer, a big scale 3D printer. So together with them, some years ago, we've been converting into probably one of the largest 3D printer in the world by then, this cobot that was used to move pallets substantially in their factory into big 3D printer. And these are the very first experiments that were done using this also complex algorithm to control the movement of the robots. And as you will see in a moment, prepare these new samples of fabrication. Again, the interesting part is also how the research of one student is then translated to the next generation. No? So this was the extruder that Sophocles fabricated in 2014, and is the same extruder then was implemented in this fabrication process to start creating this wall. Some years after, all this experience became in the Fair of Costrumat an incredible manifesto, whatever was going to be possible in this industry. So together with Tecnalia, at the end, we built a pavilion with this cage, with this huge cable bot. And we fabricated in front of all these all the visitors a wall of 6 meters by 4, implemented clay, and here you can see a little bit some of the quick videos about it. So this is the machine fabricating, and we were also using at the end drones to scan in real time. This is the space back then. And we were also using, as I told you before, drones to scan in real time the fabrication, collecting data from whatever was built, comparing this data with the digital twin, and at the end creating this transversal protocol that could really interconnect all the different actors, so the cable bot, the extruder, the material, and the data that is collected from the field. These are some of the pictures of the pavilion, and the same pavilion was then later on demolished to prove another point, was completely destroyed, and these are the last images of the pavilion, to be turned into something different, something new. So in this case, at the end of the fair, we demolished the pavilion together with Kunal Chadha, who is now a PhD candidate in ATH and was for many years a faculty in IAC. We converted this pavilion into a new material resource for the next iteration. So here, these are some of the images of the drone, of the pavilion being demolished by Kunal. completely destroyed. And aside from this moment, this is what happened after. So the year after, not only the extrusion, but also the material were re-implemented to build this big wall in the city of Valdaura, in the faculty of Valdaura, in our center in Valdaura, that could also represent, again, another iteration towards a built architecture where the wall became a proper new demonstrator on how big we could create and fabricate with this technology. And talking about big scale, let me also jump to the small scale. So many years ago, now this was 10 years ago, more or less, we built this new MRAC manifesto of the future of construction, where instead of relying to a huge 3D printer, the one of Tecnalia, we could actually depend on small machines. So what if the future of construction could also be connected to a swarm army of micro robots that start to fabricate every single robot with his own specific task, every robot with a specific goal of manufacturing, from one to another. In fact, we started to build together with our students this concrete printing solution where every single robot at the end had his own scope. Working with robots not only is connected to the topic of construction, but is also connected to the topic of habitats. I mean, that's why we won a European project together with Sony Computer Science Lab to build robots that could enhance or increase the yield, so allow farmers to produce more vegetables, more food out of their crops and lands. And this was a beautiful project that we just concluded last year together with Sony. So, which are the now series of projects I want to highlight for you to show you whatever is possible participating in the program. So as I said before, we've been fabricating and building new components that can act as novel programmable skins for our built environment, interacting with our ecosystem, also dealing with fabrication and materiality in a new sense of manufacturing, and also allowing to introduce actuators that could allow these skins to respond. We fabricated not only at the end student projects, but also real building that could at the end incorporate this solution, from the solar decathlon to the Endesa pavilion to the latest project with this artistic facade in the core of Barcelona. We've been dealing a lot also to restaurants and spaces. The first 3D printed bridge in the world fabricated with MRAC. And as you saw before, Construmat, this is the facade that we fabricated together with one of the most important ceramists and industry of ceramic here in Barcelona, in Catalonia. Again, introducing the robot not only to create just a pattern, but also to create a narrative. So every single tile in this project is transformed, is manipulated using a code, an algorithm that is reading the note of Vivaldi music and carving all these different tiles deeper and deeper according to the intensity of the music. So it's also a nice at the end demonstrator of how all this system can be interconnected and become at the end a new design opportunity, a new design to fabrication opportunity for our built environment. I think this was also another project, and you can see here the final application on site with the workers installing all our pieces. And yeah, then very quickly, this is my personal background in Numena. I'm also, I think I can show you these probably very quickly. I'm also directing, as you saw before, the company on Numeral in order to implement spatial solution in our built environment. But let me focus first again on the Master in Robotics. The Master in Robotics, the first year, is centered on understanding materiality and playing with machines and robots to learn how to design with the machine constraint. The second term, that is what we are looking at right now, is about how to implement data, so how to extract data from the physical environment and convert this data into a new digital twin that can enhance a different protocol of creativity and design iteration by implementing photogrammetry, 3D scanning, computer vision, and AI to segment and classify all the components of our space and define at the end novel protocols. All these phases that you see, these are the some of the most important figures in our ecosystem. And one important aspect of our program is also that is extremely open to collaborate with all the professionals from all the possible university research center in the world. So at the end, it's not only a master that relies on IAC. Okay, so let me stop sharing the screen for a moment. I want to take a break, and because I want to show you also a couple of other slides. But before jumping there, I would like to hear from you. Do you have any questions so far on what I show you? So we make it a little bit more interactive. Otherwise, I'm gonna speak for for 1 hour. Any questions so far, guys? Don't be shy. Eh? There is a.
I see a mic turned on from Maria Luisa.
Hello, I'm joining the program in September, actually. And my main question, I'm doing the 2 years, the MRAC 2. And about the thesis itself, I saw from the website and by talking to Serene, that has 3 options, like the startup and the thesis academic oriented and the market one, like the industry based. And within like these 3 topics, should you choose one and this is going to base your thesis, or like the thesis itself, you can choose the approach and then you can merge whatever you're researching with then starting like a model business to then become a startup? Or like, do you actually need to choose a thesis based on a problem that it is in a specific?
Let me. Understood. Let me explain it. Okay. In the second year, just for you and also for all the other for all the others also that are listening. The first year of the Master in Robotics is completely focused on exposing you to knowledge and expertise that at the moment you don't have. So I'll let you allow to understand and also explain to all of you how you shift from the digital environment to the machine and the manufacturing process, and how you can learn from the physical space and also embed the complexity of our materialities into the design solution. In the second year, the situation is different. In the second year, your role changes. So you switch from being a student to become a researcher. So you lead your own thesis. And our job, our role is to curate, to also to follow you in this process, connecting your profile to experts from the academia, from the business or the research ecosystem, and let you understand also how valuable this research can be in an environment that is not purely academic. So you have 3 options in general, but these 3 options naturally comes to you. So don't consider them rigid. depending on the direction, also the maturity of where you want to start from. No, maybe in the first year you do a 1 year research on a specific subject, and in the second year you want to say, okay, let me focus all my attention on that. Okay, at this level, we ask you, okay, what do you want to do? You want to focus on this because you would like to do a PhD study on it. You want to open a startup. You would like to introduce this solution into the office of Zaha Hadid and Bjarke Ingels, just to foster and partner. So it always comes as a conversation that we have with our students. Imagine that just 30 minutes ago, I was with Kopp Immerblau to explain to this very famous office of architecture, is one of the most famous office of architecture in the world, that we have 6-7 students for next year that are ready to start the second year of our master. And they are very happy because they are going to promote from Kopp Immerblau a subject, which is also another amazing opportunity. Imagine that you have, just to tell you this, to you and all the other 24, 23 that are connected. In the world of AI, the artificial intelligence, there are 4, 5, 6, 7, very few, I would say, people that are doing something relevant in terms of the development of solution in our practice. And we are going to put our students next to Daniel Polo Giovan, for instance, that you don't know him, but he's very, very famous AI developer, to convert all the images that Daniel is creating into physical solution. To take the expertise of our students that are, remember, are already researchers. In the second year, you are already at another level. You know how to do things that a normal architect doesn't know by far. You know how to use robotic arms. You know how to create your own end effector for the robotic arm. You know how to use robotic operating system, ROS. You know what is it? You know how to code. I mean, you know how material react. These are expertise that are really invaluable. So this is going to be one of the theses for next year. And the head of research of Kopp Immerblau was just today proposing me a topic, very humble at the end, point of view also from their side. Another office will be the one of Thomas Heatherwick in London. So also in this case, we have Foster and Partners. We have Gil Retzin, AWAR is the new company a new startup that he launched. We have Nazca.ai, which is ranked in the top 10 company of construction in the world. So our role and our mission is to bring your expertise beyond the academic environment. We believe that these solutions are ready today, and your role is to open the door of this solution into the market, which is a big responsibility.
Yes, for sure. I have a second question, but it's more like specific to this changing of the construction industry itself.
Yeah.
Because a little bit ago, when we started to develop coding and especially visual programming and scripting programming, like kind of goes to a niche of computational design, but within like mixing the robotic within the manufacturing to a point of customization, embedding how much carbon it will actually cost within the construction. How do you see this new niche of approach by this mixing design and mechatronics in a way, like, because right now we don't have like a specific name for that, like it's a mix between architecture, computational design, roboticists, like it doesn't have like a very specific name or like a category that like we can shift with being like this is a profession itself.
Let me tell you one thing first. For how many years, imagine all the conflict from architect engineer, no? How many years?
Yes.
constant, no? Okay, the architect is the one that designs, the engineer is the one that makes, because the engineer knows the material, the engineer knows the complexity of the real world. The architect is the one sitting on a desk, making a beautiful design, and then, you know, and then it's a problem of the rest of the world. Okay, these at the end bring our profession, brought our profession to a very, 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 very marginal role, marginal. So we were at the end the one that were not so much needed anymore in the equation, because also the asset of our skills and expertise. Now the topic is a little bit different. If we are aware, and not only aware, but we are in control of the manufacturing protocol, and we have tools that allow us to constantly cope with material and manufacturing complexity at the moment of the design, in the very first moment that your design leave the paper, this paper, you know, it's a completely different game. So it's a game where your design solutions are conscious design solutions that are absolutely in control of whatever is happening in the next stages. Is a moment where, now call it as you prefer, I call it a moment of maturity, when at the end you are aware of also the opportunities, because the more you are in control of this protocol, and the more and more our creativity also is enhanced by these opportunities. Okay, so it's the beginning of a new profession. And that's why you see a lot, let me tell you, a lot of architects are behind technology development right now. Why? Because of the good part that we had. The good part of our profession was to be, at the end, translators of information from multiple professionals that were all speaking to us. No? An accumulator of information is the architect, that speaks with the electrician, speaks with engineers, speaks with the client, with whatever, the craftsman. So this capability of understanding and putting ourselves in the other position is the one that is today allowing us to be in charge or lead a lot of the industrial and technological developments. So it's not only a topic of computer science, because a lot of computer scientists that also work with us are completely blown away by the way that we look into solutions. It's like the innocent eye of a creative, you know, that starts to understand how things work. And suddenly you do something that, wait a second, it's new. No one ever did it.
Yeah.
No?
No further questions. Thank you so much.
No, thanks a lot. It was nice to interact with you on that. Very happy also that you're coming for to the master. Looking forward. Okay, any other?
Yeah, this is Zabi speaking. Hi, can you hear me?
Yeah, I don't see you, but who are you? Zabi.
Yes, Zabi. I'll just turn on my video.
Hello. Ciao, Zabi.
Hey, so obviously you have students with different backgrounds and with different experience as well, interested in the program. And I've been looking at different programs from MRAC. I was wondering if, I have two questions. One was about the part-time and the full-time program that you offer.
Mm-hmm.
And the other one is your expectation or requirements in terms of skill sets. What do you expect your students, what skill sets do you expect your students to bring along, or what level?
At the end or at the beginning? Because I always look at the end.
Well,
because
I'm asking because sometimes there's a bit of, I've experienced different things when the expectations were not met. And that can be very frustrating for both sides. That's why I'm asking.
Yeah.
Let's start with the end maybe, and then
let me elaborate. First of all, as Alex told you before, I'm an entrepreneur. Just to let you understand, I'm not an academic. I'm doing a PhD, but I belong to the market. I work in the world where this technology, my role, my personal role is to implement the solution. I will conclude with a couple of things that we did in our company. And this is the bar for our students. So I'm not in the Master in Robotics because I just want to teach, you know. I'm in the Master in Robotics because I strongly believe that is a very important point to observe and learn from the state of the art. So it's a very important and crucial point for us. It's an asset to be part of the Master in Robotics. Why? Because of something that I was telling you before, Zabi. It's a master that is not endogamic. It's not done by the first faculty of IAC, the second faculty of IAC, the third faculty of IAC. It's a master that is completely designed and open to collaborate with Bartlett, ETH. I'm just telling you a couple of universities. Bartlett, ETH, Michigan State, MIT, Georgia Tech University, RMIT, and then a lot of research, Zadid, Thomas Sedgwick, Foster, Copy Meblau. So many are teaching in our master. So that's why I'm telling you, I look at my students at the end. My students on the third term, my students and Alex and Clarin students, IAC students on the Master in Robotics and Advanced Construction are extremely familiar, all of them, with the tools I was saying before to Maria Luisa. So computational tools, digital fabrication, ROS interfaces, materiality. We leave them with the robot also to make error, to learn. It's an environment where your experiments are hands-on. So now to reply at the beginning of the question, this is what I want. And when they reach the third term, they become our pilots. They become our students really at the end of this process. And you should see how beautiful it is also to look into their evolution. From the first term to the third term, you speak to different persons completely. The way that they present, the precision, that the accuracy of what they say, no buzzwords, data, physical solution, codes that are working. Third term. Now let's go back to the beginning where they are still green, let's say like that. Okay, we, with Alex, and Maria Luisa knows it, we interview one by one all the candidates that want to participate in the program. And as it happened with Maria Luisa, we asked to all of them, okay, which is your level of expertise in computation, in programming, in digital fabrication, with normal tools of a workshop. We take note. And at the beginning of the master program, 2 weeks before, if you have any hole in one of these sectors, Grasshopper, digital fabrication, programming, etc., you need to participate in a pre-course of 2 weeks. Is it enough? Sure. It's a first beginning. It's the first beginning. So we give you, from now to October, to September, a list of programs to follow up. In September, October, you have the pre-course, and then we start the trajectory. But also, I can tell you, you realize how many gates we open for you at the end of the master program. I received from Juan 2021-22 an email 2 days ago where he just wrote, I keep realizing how valuable the program is. I keep understanding nowadays how valuable the program was for me. I will show you right now in the program. And in my company, now I have Azal working, the first female student master in robotics. We had the alumni meeting 2 weeks ago with many other students that came. So it's a very strong network where you can see how this value grow also after the program is done. So don't be afraid of opening the door, open it, get out of your comfort zone. It's not gonna be comfortable, it's gonna be painful, but also insightful. I mean, changing the direction is not easy, you know, but at the end is also something that if you take it seriously, it becomes the reason why you are in this profession. Otherwise, what do you want to do? You want to end up working on AutoCAD all your life? No, I don't think so, no?
So I Yeah, AutoCAD is a thing of the past, for certain.
Exactly. Let me show you a couple of things. Tell me.
No, it's thank you for your response. I think it was a good response. Thank you.
I just also want to show you a couple of things from our side, just to say again what I was commenting. Let me share just very quickly. We have a few minutes left, but I want to share with you this part. So, okay, so, yeah, let me move this because I want to share it. So very quickly, to go a little bit more in detail, these are the three verticals. So the computation, the design ecosystem, the manufacturing ecosystem, and the one of materials. As we said before, these are the challenges that we are facing. In the first term, this is the guy that you see there is Hendrik, and now is also opening a new full department of robotics back to Germany, and he just got a robot. So he's also bringing immediately, directly from day one, all the knowledge and expertise back in his country, and further on introducing it in a new ecosystem. So in the first term, you learn how to design with machines, so with the machine protocol and limitations. In the second term, as I said before, you digitize your physical environment and you start to embed all the possible computational system into it, from computer vision to machine learning, spatial segmentation, and so on. In the third term of the first year, you co-design, you co-create, or you co-fabricate with these tools, with these machines, starting to open up to this cyber physical space that we were commenting before. So this is the normal organization of our master. You have the research studio that always absorb all the expertise and knowledge from the software seminar, the hardware seminar, and the theory seminar. And along the master program, twice per term, everything is interrupted. So you stop, you left everything that you are doing on the table, and you jump into a research topic with experts that are coming from the universities that I was telling you before, or the companies that I was telling you before. So it's also a beautiful moment to open up to other voices, no, that participate in this conversation. In terms of software, we teach computational design with Andrea Graziano, that doesn't need any introduction, I think. With Mateusz Zeberdzewicz, we also work on the part of AI, and we also introduce Ross with the robotic engineers of EURECAT. And then we have 3 seminars of hardware 1, 2, and 3, where you will learn how to fabricate your own end effector and create interactive sensors that can allow us to cooperate with machines. The workshops are the one that I was telling you. The list of workshops that we did is endless, and I really challenge you to find another university in the world that has this variety of topics in one single program. And then the studio. The studio is a moment where creatively we can also understand how all this solution can encode the new design to manufacturing manifesto for our physical spaces. And then the second year, as we said before, it's all about your thesis, where we become the mentors of your research. We connect you with professional environments that can expose your skills and knowledge to the real challenges that are happening in our world. And as I said before, we work with a lot of companies in this second year. This is the one of Nazca.ai, previously called Scale Robotics, the first company to introduce a scanning solution in the built in the construction site. EURECAT, which is one of the most important research center of Europe, where we don't only collaborate, but I also teach. They teach in our master. Gil Retzin with our ONA. This is my company, Olla Macchina. I'm skipping now my project, but We built the first 3D printed shoe store in the world. We built the Spanish pavilion of the Expo Dubai, the BAFTA Theatre in London, the WOW Commercial Center, the Riyadh 3D printed shoe store. Now we're collaborating with Thomas Saraceno. We have 2 projects in the Venice Biennale and so on. So I invite you to look online what we did. With Zadid Architects, we are now, this is amazing, 2 students of us from the first year, they set up a construction site in Honduras, in the middle of an island, working for Zadid, and they are the 2 leading in charge of this task. So they are going to use the local material to build this new resort from Zaha. Then we work a lot with WASP, which is the Italian company for digital fabrication, Ceramica Gumeia, and so on. So this was a very quick, and this is one quick preview of a workshop that we did with some of our students. But the interesting part is that you can see also how does it work, no? One of our workshops. So this was done last year, and you have this robot that reads the environment where it's moving, and it picks all pieces from tiles and start to adjust them in a constrained space. So you need to program the robot to recognize individually every piece. You need to program the robot to release every piece in a specific position. And we've been doing that, also collaborating with, again, several experts, also from IPH, that were teaching with us in this program. So quite exciting stuff. Okay, so that's it. I think this was the last part that I wanted to show you. Any other questions that you have?
Regarding materiality, specifically bioplastics and clay, what is the approach of the program specifically with bio-additives? Because we can only do so much by not being a material engineer, but like also looking for a design point of view.
Yeah.
And like, what are the research and the background specifically to building with bioplastics and bio-additives to clay?
Okay.
Specifically specifically to my background, because I come from MTech, and by my research on MTech, the final dissertation, we created a concrete made out of entirely sand-based, not using sand for mining. And I wanted to actually bring this type of new types of materialities, implementing bio-additives specifically to clay.
Maria Luisa, are you doing the second year also?
Yes, the second year.
Yeah? Okay.
Yes.
I have the good company for you.
Specifically to Brazil additives, because this is my context, this is where I'm from, because the sand concrete was for the UAE context. So my question is, how do you guys approach these new types of materialities from a design point of view, or like more as a explorer within these 2 fields?
Look, the design point of view cannot be disconnected to the material behavior. So it cannot be disconnected to the physicality of the product. So in terms of the specific world of concrete printing, eventually for the second year, as I said before, we have a very, very good industrial partner that is deploying now solution for the world of 3D printing in construction in concrete. And I visit them. I was visiting them 3 weeks ago. It's impressive what they're doing. And it's also impressive to see how they study the material. Because the real secret there is the material. So the nice part in this workflow is to see which is the approach. How they observe the material, how they create the mixture, how they observe the material, how they extrapolate data from the material observation, how they stress the material in order to test mechanical characteristics of the product. So in that sense, we have a large experience in the ecosystem of clay, and for an eventual second year, as I said before, picking from our ecosystem, I guess we have all the expertise to combine on a specific material research that can point towards the lower down of what you should try to do of chemicals on the hardening of concrete, if you want to be a little bit more specific on that. Because what they do on 3D printing in concrete, they normally boost the 3D print with a lot of chemicals that are allowing the 3D, the concrete not to crack and open while drying. But yeah, it's good, but you know. So I think it's a good topic where you could leverage a little bit of research. And aside from this, Maria Luisa, IAC is a huge place where you can also observe whatever else is happening around you. So the interesting part is that imagine on materiality, we have part of our ecosystem, we have Areti Markopoulou, we have the matter fad that is here, which is one of the, you know, probably the matter fad, material connection. So a lot of material libraries that are, and material experts that are collaborating with us, teaching with us, and developing with us solution. And I think it's also another undeniable, valuable asset for our program.
Amazing. Super excited to join September.
Happy. We do it with passion because it's really a master that we love to guide and to learn from. Okay.
Any other questions?
Sai, probably.
Hello. Yeah. Yes.
I'm really fascinated by the things that I has done and really looking forward to do something. So what would be the difference with the MRAC 01 and 02? For example, 02 will have an opportunity to do the thesis part where it deals with the real life applications and interacting with the industry and researchers. So how would MRAC 1 will have an opportunity to deal with some kind of a project in a real life situations,
Okay, the MRAC 01, as I was telling you, the MRAC 01 will expose you. Basically, we'll start, you enter a room and we start to open all the doors and show you, the path across these doors. So we will put you in contact, direct contact. You will be sitting with these experts. So, for instance, for the first year now, we are planning a collaboration with COP in Meblau and the TU University of Vienna in the first term. We will see how to embed Foster and Partner or other experts for the second, etc. And although this happens, it's like choosing a small chocolate because we are going with Alex to many conferences. I was now in Berlin for the conference on the future of AI. I just spoke with Olive Robotics. It's a nice company that is focused now on sensing. And Benjamin Friedrich is in fact is the CTO of this company, and it comes from ICT. So it's all a connection where we completely push constantly, but the students out of a purely academic and speculative environment. But nonetheless, the first year is a year where we need to explore. You need to test, you need to make mistakes. So we also don't want the discourse to be too extreme on the exploitation of technology in the business, in the market. That's why we have the second year. In the second year, imagine that you have courses with ESADE. ESADE is one of the most famous economy university, probably the first university of economic in the world, in Europe, and the number 5 or 7 in the world. So, and this is again because I was pushing a lot to say, look, wait a second, what happened when you finish the university? You don't know what is a business plan. You don't know what is a valuable proposition. You don't know which are the channels of your to promote your program. You don't know what is EBITDA. You don't know what is a cash flow. But it's not a course that is purely based. Okay, let's do a business plan. It's a course, the one with them, that is focused on understanding which is the gap. Understanding the gap is understanding where you need to operate to introduce your opportunities. So reading and seeing also what the market tells you. So that's why I'm telling you, the role of the second year is to expose you to this reality. Okay, the first year to expose you to experts, but knowledge. Based on knowledge. The knowledge is the most important part. Okay, on the first year. Even though the studio is now continuous from the first term to the third term. So your ideas will pass to the hands of Maria Elena and Vince. There are two faculties that are now teaching with us since 3 years, and they were leading the robotic department of Bartlett in London. So people extremely knowledgeable. Then you will pass in my hands for the second term. That will be about sensing, computer vision and machine learning. And in the one of Alex for the third term, where it's going to be about human-machine interaction. So it's also beautiful to see how the same idea can grow through the adoption and implementation of all these layers. Now I'm drawing a few names. Okay, sensing, human-machine interaction, but how this can help your project to become better, more mature. And this is what you will learn in the first year. Okay.
Thank you.
You're welcome. Good. Okay. So Sarina, I think we can close the session if there is no more. Any more question? Thanks to everyone for attending. Thanks thanks Maria Luisa, thanks Irene, eventually, clearly, for being there. Look forward to see you now or in Paris. In Paris, there is a very nice conference about the future of construction. It's called Built World. Have a look at it. It's going to be in June. And also I would like to invite you to have a look at the future of construction, which is another conference that's going to happen in September. Should be organized, if you look online, should be organized by the University of Munich, if I'm not wrong. Okay, so that's it. Thanks to everyone, and have a nice afternoon, morning, or whatever is or evening. Okay, so see you soon. Goodbye.
Thank you all. Bye-bye.
Thank you.